Welcome everyone to CannaGrow Expo. Thanks for being here Saturday morning to listen to the presentation. So I guess I'll introduce myself. My name is Drew Plebani. I'm the CEO at Commercial Cultivator, and a little background about myself. I went to college for environmental studies and geology, and basically started my cannabis career around the same time when I got into college in California, just after Prop 215 was passed. A lot of what I'm going to present to you today is, some stuff that I learned and was first introduced to in college, and some of that sort of created a framework for my continued learning about sustainability, about how to incorporate sustainable practices into the cannabis cultivation and beyond, of course. The title of the presentation is Regenerative, Sustainable Cultivation Systems and Soil Building. Recently, this past week, I had the opportunity to go to a sustainability symposium here in Denver, and it was pretty interesting. For years, I guess I've thought about sustainability from my own unique mindset. And maybe I wasn't really up to date on the kind of level of greenwashing that is occurring in, all over the place. So I kind of wanted to run through some definitions of sustainability and make sure that what we're talking about, or for the purposes of our discussion, we're hopefully on the same page. The first question that I asked was, what does it really mean to be sustainable? When I think about it for myself and break it down, it's pretty simple. Able to sustain, or the ability to sustain. When you look at, some various dictionary definitions of sustainability, I was honestly sort of surprised at what was in the Merriam-Webster dictionary. The first definition, able to be used without being completely used up or destroyed. That, in my mind, wasn't really what sustainability, it's not what it is for me. In my thinking of it, it's about, at least keeping things at a baseline, but hopefully we're moving them forward, because that would at least increase the sustainability. And so in terms of, just kind of the broad concept of sustainability, I think this is a pretty good quote. Sustainability is a lifestyle where you give back more than you take in order to ensure the wealth of life's future generations. And so, when we're talking about sustainability, there's a pretty broad spectrum. Are we creating a net positive effect? Is it neutral? Or is it negative, but just not so negative, and we can still slap that word sustainable onto it? So kind of further on the topic of greenwashing, I came across this on Monsanto's website. I don't know how many of you guys have been on their website lately, anyone? Our vision for sustainable agriculture strives to meet the needs of a growing population, to protect and to preserve this planet we all call home, and to improve lives everywhere. In 2008, Monsanto made a commitment to sustainable agriculture, pledging to produce more, conserve more, and improve farmers' lives everywhere by 2030. So, I don't claim to be an expert in Monsanto, but that certainly wasn't my impression of, the end result of what they were doing. So, I found that pretty telling. At the sustainability conference that I went to this last week, there were some questions about greenhouse cultivation, and one of the light manufacturers said, well, actually, I don't think greenhouse cultivation is going to get much traction because consumer demand, the people want indoor quality cannabis, And I thought to myself, I thought we were talking about sustainability, So you mean to tell me that your light uses less power, so you can call it sustainable? Is that really sustainable if we use 50% of the fossil fuels that we're currently using? Is that sustainable? It's debatable, I guess, right? Okay, good. People debate it, though, for sure. Awesome. So, in terms of, specifically sustainable cannabis, at that, at the Sustainability conference that was held here in Denver this last week, there were a few different, different metrics that were posed in one of the energy efficiency segments. And you guys have probably all heard, or maybe some of you have heard, what do you get in grams, how many grams per watt, right? That's sort of a layman's metric for how well is your garden producing. So one of the panelists proposed it should actually be how many pounds do you get for how many kilowatt hours you used, which I think is definitely it's a little bit harder to determine, but it's a more appropriate metric. But really, it doesn't come down to, well, how efficiently is your lighting system, your HVAC system. It comes down to the totality of your grow and, where your fertilizer inputs are coming from, how they were created, how far they were trucked, your potting soil media. All of those things have an impact in terms of the carbon footprint of that operation. And so actually looking at that, I think, is really the only way to assess true sustainability is, well, how much CO2, how many pounds of carbon for pounds of cannabis? And that's probably a pretty difficult calculation, but I think it's, I hope that as the industry progresses, we'll get to see that used. So, back to kind of sustainability and a bunch of the things that have characterized, my opinion, some of my beliefs, methodologies, and so on, revolving, sustainability, how to incorporate, organic cultivation practices, and so I'll just kind of go through the list here. Permaculture, which is one of the things I got my start in college, that very much changed the way that I look at all systems in general, not just cannabis cultivation systems. And then there's natural farming, biodynamics, biointensive, regenerative agriculture, holistic management or holistic ag, ecological agriculture, and there's no-till. Are you guys familiar with the majority of those things up there? No? You guys know a few of them, maybe? So no-till, I think, is something that's utilized in quite a few of those different methodologies. No-till specifically would be where you're not going back in and tilling. I think the most accepted and kind of basic premise on no-till is that once we acknowledge the existence of the mycorrhizal network, then we start to think about, well, do we want to go through and slice and dice our mycorrhizal network in order to achieve something? And so depending on the situation, depending, whether we're talking potting soil, containerized potting soil, or broadacre agriculture, true, soil, the approach is a little different. Tilling is typically utilized to obviously, reinvigorate the soil, put that organic material back in. And then at a certain point, certain people have found that it actually makes sense to not till it anymore because you have less erosion. You're able to, manage the system in a different way by keeping it basically, covered in a perennial cover crop. So we'll get into some of that stuff a little further into it. But so, permaculture, I'll go through them real quick. Permaculture started in Australia. Bill Mollison, David Holmgren, I think in the late 70s. And it's basically, some of the core principles are care of the earth, care of people, return of surplus. So that return of surplus is really a big thing for me in the way that I look at systems. What that return of surplus really means is that system is giving back to itself. And another sort of facet to that return of surplus is that when you design a system with permaculture ethics, you don't design anything to only have one output or one positive attribute. Everything has to perform multiple functions in that system. So there's nothing that's just doing one thing. You have chickens, and the chickens can lay eggs for you, but they can also till the ground for you. They can do pest management for you. And so designing the elements of the system so that they actually work together to produce, you know, a greater sum of outputs collectively than just, say, a monocultural approach to, you know, whatever it is. So when we're talking cannabis cultivation and even getting into, you know, deeper sustainability with cannabis systems, obviously we're still talking about cannabis being our main crop, you know, potentially in that system where that's our cash crop. That's the one that's going to make us the most money. But in terms of minimizing the cost of inputs and all that kind of stuff, it starts to make sense to think about how to design the elements so that they work together. So kind of the thing for me, you know, I probably don't have time because I got a ton more slides and I started late to go through all of these, but if you guys want to come to the booth and chat it up about any of this stuff, or, you know, Google's pretty handy. You can always do some Google research. But anyways, for me, you know, what these all kind of have in common, they're a bit distinct, but what they all, I think, have in common is that they've sort of looked to the natural system to figure some things out. You know, they've looked to Earth systems, to ecological models, to say, okay, well, how can we, you know, how does this system that's been working, you know, for millions of years, how can we tune into that progression? How can we work with nature instead of against it? So this is one of the things that I came across, I think, for the first time when I was in college as a geology major. This is basically shows, you know, kind of a representation of the geologic time scale. So I don't know how many of you guys know, but according to the geologic record, you know, flowering plants first appeared on Earth 130 million years ago. When I was in college, I picked up a little, or I acquired a fossilized pine cone that was 115 million years old. And it kind of changed my perspective on, you know, looking at terrestrial ecosystems, at geology, at the forest, and just, you know, the time scale, just, I'm still in awe. You know, there have been conifers on Earth for 100 million years. That means that basically something's been feeding them, you know, for that time period. So, you know, one of the questions that I asked, you know, once I realized, wow, you know, hundreds of millions of years these plants have been here. Well, obviously Monsanto wasn't around dropping petrochemical fertilizers on it to, you know, promote maximum growth. So there must have been some naturally evolved existing mechanism, at least for, you know, a good 100 or 2 million years now. So tuning back into that, I think there's a lot that we can learn. You know, obviously, you know, at the onset of terrestrial ecosystems, there wasn't much soil. You know, so there is this evolved capacity for plants and biology. You know, macro, micro, you know, animals, soil biology to work together to do this amazing thing, which is basically create soil, create humus, and create ecosystems where plant species can thrive. So I want to kind of take a step back from talking about that just to talk about soil for a sec. How many of you guys have seen this before? All right. So if you've ever taken a soil science course or probably looked around on the internet, you've seen this. The reason I'm putting this up here is because one of the other things that kind of blew me away at this sustainability symposium was, and I won't drop any names, but, you know, a pretty big gentleman in the industry was asked a question about, well, what do you think about using soil for your indoor grow? This guy has a, you know, state-of-the-art hydroponic facility. He said, his response was, well, I don't think soil has any place in indoor cultivation, and there's just no way to achieve the maximum benefit of soil inside. And there was another scientist gentleman there kind of sitting next to him on the panel, and he said, well, I just want to back him up and say that he's totally right, that you would never use soil in a containerized gardening system. You'd use a soilless medium. You'd use cocoa, you'd use peat, right? So just to make sure, again, that we're clear on our definitions, soil, well, on that one, obviously soil, from the earth, built from, broken down rock, is comprised essentially of sand, silt, and clay, and organic material. But when we're talking soil in terms of cannabis cultivation, it's a limited few of us that actually probably utilize that site soil. There's a lot of strategies to do that. Probably won't have time to go into that today, but if you're curious about how to amend your existing site soil and grow cannabis in a more broadacre agriculture type of setting, that's a great conversation that we can have at some point over the weekend. But so soil, potting soil, pretty much the same thing as a soilless media, in my opinion. The main difference is that maybe with the potting soil, you've got a little more diversity of organic material. Maybe you got a little compost, maybe you got a little bit of amendments, stuff like that. Where a true soilless media, maybe it's just cocoa and perlite, let's say. Then kind of down below on that, you have living soil or naturally created soil or humus. So kind of the main distinction, in my mind at least, between potting soil or soilless media as compared to a living soil is mainly, the activity and the relative proportions of members of the soil food web. You guys all hear of the soil food web? Yes, no, maybe, mostly? All right, awesome. The soil food web's a thing that I've spent a lot of years thinking about and studying and trying to understand how it functions and applies in terms of, cannabis cultivation specifically and in terms of, sustainable cultivation in general. So obviously the soil food web in some shape or form has pretty much been the mechanism that's created plant available nutrient on Earth for the last couple 100 million years, let's say. So you guys already know about it. I'll try and go through it pretty quick. It's comprised of bacteria, fungi, protozoa, nematodes, arthropods, earthworms, and essentially, all that leaf litter, grass, root material, dead root material is all being broken down by the soil food web. They're eating each other, they're leaving their remains, their detritus, their bodies, their effluent, and they're contributing that all to the system. That system is essentially, in a natural sense, and even in the sense of a potting soil, that system is pretty much undergoing a continual, or trying to undergo a continual progression. That's what's happening on Earth. So we see this progression of terrestrial ecosystems where we start simple bacterial grassland type setting. And as the soil and the above ground plant species kind of progress forward, what you find is that then, if you didn't mow your backyard, let's say, for a year or two, what would it look like? You'd start to have shrubs growing up. You'd probably start to have a couple trees popping up here and there. And so that's the natural progression of ecosystems, from simple to more complex, from bacterial to fungal in terms of soil types. So one of the amazing things that happens is that, you start off with something simple. You're growing grass. That grass, or whatever you're growing, whatever that first crop is, it's depositing root mass into the soil, So when we're talking about sand, silt, clay, ag soil, site soil, the process is that we're really focused on building the organic material component of that soil. When we're looking at potting soil, containerized living soil systems, the benefit of getting something else growing other than our desired main crop is that we're bringing that soil to life, because all of those roots, whether it's cannabis roots or clover roots or oat roots, they're all giving off exudates. Those exudates are attracting beneficials to them. And that's the way this part of the soil food web works, is that the plant is trading mycorrhiza, sugar, for nutrient. And the mild carbonic acid that's being exuded from the roots is attracting the beneficials that help protect the living roots, the rhizosphere, help cycle nutrient, and help to make that a happy system. So, as we're, the progression is distinct, obviously, if we're talking about starting from a potting soil or starting from an ag soil. But ultimately, what we're looking for is to arrive to the same place, hopefully, and that place is, where our plants are going to grow the best, where we're going to have the most productivity from our systems. So along the lines of that progression, like I said, the systems are moving from bacterial towards fungal. One of the interesting things is that system inherently has developed the capacity to be sustainable in a true sense of the word, because that system continues to, add the surplus back to itself. So there's no loss, really, in a natural progression. The root mass of a plant species, let's say an annual that's died, is now food for the decomposers in that system. And, the next crop species, the beneficials that are attracted to the exudates from living roots are going to migrate to those living roots. So in a natural system, you don't really have this competition. You don't have, in a balanced system, you don't have problems like root rot and things like that, because you have the appropriate decomposers to decompose the dead organic material, and you have the appropriate beneficials to occupy the living rhizosphere. So this kind of goes through bacterial versus fungal diversity. I'm not going to read it all out, but basically cannabis prefers a slightly fungal dominant system. So fungal dominant, what does that really mean? If any of you guys who have looked into compost tea, soil food web systems a little bit more, you may or may not have come across bacterial to fungal ratios, or fungi to bacteria. And that's basically one way of taking a slice of your soil system and looking at it, getting a representation of sort of where is it on that progression of bacterial to fungal. The interesting thing to note is really that progression, like I was saying, is stimulated by itself. So when we jump into, at any point in that progression, we need to be aware of that where we want to go is also greatly influenced by where we started, So we can't get to a truly fungal dominant system without having the appropriate food sources for fungi. And naturally, in the natural progression of a system, the more woody material that's developed, the more that ecosystem progresses from grasslands to forests, from bacterial to fungal, the more woody material, the more carbon-rich material, the more food for mycorrhiza, for fungi that there is. So what does fungal dominant really mean? To me, there's a bit of a misconception that's being forwarded out there in terms of like, okay, we know we want a fungal dominant system. So how do we do that? We go find a fungal dominant forest humus, or we pre-culture some compost and make it go fungal. And then we extract that. Now we look at it under a microscope and we say, aha, now we have more fungi. That's what I wanted to see, more fungi. And we can kind of say, yeah, this is good fungi, this is bad fungi. But when we start looking at the ecosystem that we took that material from, if we're talking about cannabis cultivation, well, none of that fungi is really very functional for us. It's all ectomycorrhiza or it's all saprophytic mycorrhiza. There's really not much endo going on in that forest humus. So if we want an endomycorrhizally dominated soil system, well, how do we get there? Well, obviously we need the appropriate food sources for that mycorrhiza. And in a natural setting, that system has built itself up with the food sources to give itself that progression. When we're jumping into it, that's something that we need to be aware of, because it's essentially and I'll get into this a little bit more later, that's one of the biggest limiting factors, is what is the food source for your soil food web? If that soil that we're trying to take to fungally dominant hasn't been created over hundreds or thousands of years, then maybe we're missing some of those inputs that were created from within that system to feed that system and progress it forward. So kind of back to sustainable, on the soil side of things, to me, sustainability comes down to soil building. So you can improve the existing site soil or the potting soil. You know, the process is a little different. The end, you know, the desired result is a little different, because in a potting soil, you're not really devoid of organic material. You know, it's mostly organic material. Not necessarily broken down organic material, but it's mostly organic material with maybe some perlite or some pumice or, you know, something else for that physical pore space. So, you know, we can basically both improve site soil, you know, sand, silt, clay, ag soil, or we can improve potting soil. It works the same way. How we manage the systems is a little different. And, you know, dare I say, sustainable systems can be implemented across, you know, all aspects of life in general, not just, you know, how do we build our soil or, so soil fertility improvements are sustainable. So that actually means, you know, increasing the content of soil minerals, you know, the available nutrient and the organic material component. It's kind of hard to know that you're doing that, other than, you know, visual assessment of plants. The kind of the easiest way is to, you know, take a soil sample, send it off, and see where you're at. Because, you know, a living soil hinges on pretty much what, you know, a conventional ag soil has been, you know, what chemists define as what's necessary for a conventional ag soil. We need, you know, balanced chemical. We need appropriate physical. So the medium has to drain, right? It's got to hold water. So I came across this study recently, and this is a pretty old study, but this study suggested that, now I'm not referring to worm casting so much as I'm referring to a soil system that had worms introduced to it. When the soil data from the soil system without worms was compared to, you know, the system with some retention times of worms in it, they found there was a 5-time increase in nitrogen, a 7-fold increase in phosphorus, and an 11-fold increase in potassium. That's pretty incredible, you know. So I'm not at all suggesting go out and, you know, just pile worm castings on your system. Really what I'm suggesting is add some worms to your system, because they've been around for a long time and they're a big part of what enables a living soil system to actually function. They facilitate the physical characteristics, they cycle nutrient, and they also, you know, they decompose a lot of bacteria, so in a certain sense they are helpful in enabling that system to progress towards fungal dominance. Because if you have too much bacteria, you don't have anything to eat your bacteria, your system's not going to do very well, because that fungal system, again, is built on, you know, the excrement, the remains, and the biologic nutrient cycling process of moving towards that in a natural way. So I think I've kind of covered a lot of this stuff. You know, cover crops, pretty important. So we'll compost tea, soil inoculants. So we'll kind of breeze through cover crops real quick. If we're talking about indoor greenhouse, kind of perpetual systems where there's not really an off season, let's say, typically speaking, when we're talking cover cropping in containerized systems like that, most of those plant species aren't going to finish in terms of, you know, the clover. You're not going to, you know, you might be able to get some clover seed from it, but most of what's going to grow up is either going to die back because there's not enough light, or if it's growing crazy, you're probably going to choose to chop it down and lay it back down as mulch. And that's a really big, huge thing to note. You know, for years I grew in soil, potting soil, you know, different types of growing styles, and I didn't get into mulching. And when I got into mulching, it just changed my whole cultivation style. The whole reality just shifted. And it makes a lot of sense when you look at the natural model. What do we see in the forest? There's a leaf litter layer, right? You dig around through there, you'll probably see some arthropods, some beetles, some microarthropods. Those guys are really important to the system, and they won't be there if you don't have a mulch layer. The majority of our biologic activity in a naturally built soil system is that top inch, maybe even half inch. So if you don't have a mulch layer, that top half inch is going to get hot and cold and too wet and too dry, and that's not at all where our soil biology wants to hang out. So they won't really hang out there for us. Wood chips is also a good mulch. There's conventional, there's conventional ag kind of mindset about adding too much carbon-rich material. What it'll do is rob the nitrogen from your soil, because you need a balance of carbon and nitrogen for that carbon to break down, basically. But wood chips is a great, is a great input, and there's a few different ways to actually utilize more woody material than is, conventionally agreed upon, by buffering some of the other inputs to facilitate the breakdown and things like that, which I would go into, but then it'd start to be a sales pitch for my stuff, and I can't do that. So, okay, so annual cover crops. Obviously, I think we've gone through it. Organic material. We're going to bring in beneficials if it's an open air environment where beneficials can come in. And then obviously chop and drop, no-till, would be laying it on top. Tilling it back in would be a strategy appropriate for if we were building that site soil and we really wanted to increase the soil tilth a little bit faster and sink some of that organic material down into the soil strata. The thing that happens with that is the first sort of set of soil biology to come and eat that organic material, that green material, is going to be bacteria. And so when you till a cover crop back in, you pretty much create a bacterial-dominated soil type until most of that bacterial food is decomposed. So that can be good, and either way, tilling that, improving that organic material component is good, but it might not be exactly what we want if we want to stick a cannabis plant in there straight away. We want some time for that bacteria to decompose that green material and try and push that system towards functional fungal dominance. So yeah, here are annual cover crops. So here's a list of cover crops. In terms of indoor containerized, no-till cover crop, do whatever you want. Just throw it in there, see what grows. You might make some observations about, wow, I had almost no germination of this species, or wow, that species really dominated, or man, that was a pain. I don't think I want to do that one anymore. And like I said, ultimately you'll probably end up going through and cutting that down in an indoor containerized system, because you don't always want your oat grass up there with your colas. Depends what you want. But so perennial cover crops, clovers, fantastic. They're really friendly. They're really healthy and happy and nice to have in the garden. Kind of jumping back, I think I touched on this earlier, but when we're talking about turning a potting soil into a living soil, one of the best things that we can do is actually do a cover crop, because like I said, those living roots are going to stretch out. Even if they don't do that well, they're going to stretch out, and they're going to photosynthesize, and they're going to give off exudates, and that's going to attract, if you have a soil that has some life, or if you're doing compost tea or doing inoculants, that's going to attract beneficials to the roots of that cover crop. And even though you might say, oh, well, that's taking a little bit from the system, really what it's doing is bringing it to life. And that organic material, that carbon, is pretty much going to cycle back in with, I think, especially if you have worms in your system, a net positive gain. So I'm going to run through a few more things here in terms of what we can do to kind of improve our system. Compost, obviously, I don't think I really need to talk about that too much. Pretty important, pretty helpful. Good compost is made from a diversity of organic material. That diversity of organic material is what helps to sustain that diversity of biologic life in terms of the soil food web. So yeah, water. I'm going to blast through this, and then I'll talk about it more so I don't run out of time. Oh, yeah, here, I can run it back for you. That one. So the next thing kind of on the list is water. Obviously, water is pretty important to our cultivation systems. Whether we're talking about being sustainable or not sustainable or whatever, you know, obviously we can't grow without water. So, you know, just to touch on it, if you guys are thinking about building out systems, augmenting your systems, developing systems, whatever, consider rainwater catchment. Consider permaculture, water harvesting, planning, and design. And consider trying to build a system that doesn't create any wastewater. It's doable. You know, people tell you maybe that it's not, but it's very doable. So, you know, in terms of water, obviously, irrigated landscape, you're able to build soil faster if we're talking about broadacre agriculture. You can, you know, do more with cover crops. And also, you know, if we're talking about outside again, you can build soil pretty well in the off season. And, you know, the strategy for, you know, seasonal soil building versus how you implement and approach soil building in a containerized system is somewhat distinct. There's some overlap. And then, you know, if you're in a container, definitely don't let your soil dry out. Don't let it go bone dry in between cycles if you plan to repurpose it, because a lot of that biologic life that you so lovingly, hopefully, cultivated in your soil is getting pretty diminished and baked out, and probably either leaving the pots if they can. You know, you'll see mass migration of worms and stuff like that, or other biologic populations from containers when it's not quite right to suit their needs. So again, mulch, super crucial if you want to do a living soil system. It really is the first place to start in terms of creating a hospitable environment for a lot of that soil food web. And like I said, you know, act like the forest, think like the forest. There's leaf litter. That really is helpful in creating fungal dominant systems. Okay, so limiting factors. I think I kind of touched upon this. We've got basically, if we're talking about soil, we've got the physical characteristics, right? We've got the chemical. Is it chemically balanced? Nitrogen, phosphorus, potassium, calcium to magnesium ratios, trace minerals. All this stuff needs to be in a decent range in order for, one, your plant to be relatively happy, and as well, it's helpful you know, for the soil food web just as much as it is for the plant to have balanced chemical concentrations. Then kind of that third limiting factor, the limiting factor that I think most cultivators looking to taking any sort of soil medium, potting soil, and moving it towards a living soil is the appropriate food sources for that soil food web. When we look at a normal potting soil, it's probably got a handful, maybe a dozen, maybe 20 inputs if it's a good one. But typically it's probably peat, perlite, maybe some cocoa, you know, some calcium, some magnesium, little pH balance, you know, some trace minerals. Kind of depends on what their sources were. But regardless, you know, they've done a pretty decent job. If you can plant a plant in it and it doesn't kill your plant, then chemically it's all right, physically it's all right. But they probably haven't taken care of really looking too deeply into the balance of soil biology that's most appropriate. And even if they did, unfortunately, when you stick it in a plastic bag, smash it in a pallet, plastic wrap it, and ship it in a semi-truck from California to Colorado, let's say, it's been diminished. So that's one of the biggest, to me, the biggest limiting factor is, again, food for your soil food web. What does that really mean? Well, again, what's good compost? Good compost comes from a diversity of organic material. That diversity of organic material feeds that diversity of biologic life. So without that diversity of organic material, we won't have very much success because we won't have food for our biology. So we'll be in a cycle of constantly reapplying some form of inoculum, compost tea weekly maybe. So that's definitely what I did for many years as a compost tea brewer. We were on weekly compost tea applications. Plants were happy, seemed to work well. After some years of doing that, what I came to was, well, if it's truly beneficial, it should stick around. And if it's not sticking around, then either it's not truly beneficial or you've got some limiting factors in your system that need to be addressed. So, you know, the more I got into, you know, looking at potting soil, well, like I said, physical, chemical, pretty well taken care of. So why am I reapplying this biology? If it's truly beneficial, my plant likes it, you know, visual confirmation of that. If we look under the microscope at the soil, we see improvements in soil biologic populations. So, you know, yeah, it's just that food source, thinking of, and figuring out and understanding, you know, that progression of ecosystems. What has that natural system offered to that soil that hasn't been replicated in the recently made soil that was made, you know, last fall from some bark mulch, some ammonium nitrate, and some perlite and some trace minerals, and they blast it out there and charge you for it pretty well. You know, there really isn't, one, it's not a naturally evolved system, so it's missing a lot of those contributions. And two, you know, there's the reality that some of that biology, even if they did go to extreme measures to really, you know, make sure that it was there, isn't going to transfer that well in your bag of soil. So how do we get it into the soil? How do we, you know, basically sustain a healthy soil food web? You got to bring in that biology in some form. So compost tea is typically probably going to be one of your more cost-effective approaches. There's some soluble inoculants that are lab cultured that are, you know, designed to sort of emulate what you would get from a tea. But basically bringing in that soil biology. So whether it be, you know, humus, compost, worm castings, a combination of those things, those are all really important as our primary source of inoculant. Then if we're talking about endomycorrhiza, it's really important. I didn't touch on it too much in this talk, but you want to be inoculating your plants with endomycorrhiza straight away once they have roots. That's the cheapest, most cost-effective way to hit them. Once they've been inoculated, they will grow together. You shouldn't need to reapply mycorrhiza. They're one of the most resilient soil food web populations there are. So inoculate when it's young, and then our whole approach really is feed the soil, you know, provide those organic materials that are the main source of limiting factors. So I'm running out of time because we started a little bit late, but I want to try and blast through this. Here's kind of a quick overview, and I could honestly give a whole 50-minute talk on this slide right here. But basically, cannabis soil management models. There's model A, once and done, cocoa, typically. Add salts, grow your plant, throw it away. There's option B, once and repurpose. Grow your plant, maybe you leach the cocoa, maybe pull the roots out and leach the cocoa, mix it up, add some more, go back, use it again. Maybe just pull the root balls and leach it and do that. I know some people that run several cycles in cocoa and synthetics by just, you know, basically flushing. Or there's C, which is living soil. It can be used indefinitely. You bring it in once, you leave it there. It's kind of like the rest of the earth, you know, the way that it works. The soil stays there. We don't have to go through and dig out the dead roots from the forest because we're worried about it killing the rest of the forest because there's root rot. No, there's the appropriate biological populations to break down, you know, the organic material that once was living roots and turn that into food for other biologic populations and for the system, of course. And so when we kind of get into, you know, a high-level overview of these three kind of concepts, essentially what we have is, you know, so I'm going to use this example, 100 light flowering operation. They're doing 6 plants per light in 5-gallon containers, cocoa. So a 5-gallon container is actually a little bit less than 5 gallons of soil, but for the purposes of this, we'll just call it 5 gallons, right? So that means that they're using basically 3,000 gallons of soil every flowering cycle. Let's assume that this system is split half and half, so they're harvesting, you know, half one month, half the next month. So they're using basically 1,500 gallons of soil per month in that system, which is roughly, you know, it's probably more like 6 yards, 5.5 yards, but depending on, you know, the actual container size, the veg, all that stuff, we'll just call it 8 yards a month for that system. So depending on the cost of that input, let's just say it's a couple $1,000 bucks a month. In terms of sustainability, really what it comes down to, for me, when we're looking at commercial facilities, it's really operational efficiency. You know, your soil shouldn't cost that much, your nutrients shouldn't cost that much if you're operating at scale. But your labor, if your labor's not working too terribly efficiently, that's going to cost you more than almost anything. It might even cost you as much as your power bill if you're indoor, or more. Because, you know, let's say you're doing this once and done, Model A. You know, you've got to cut the plant down, and then someone's got to take those pots. Maybe they have to carry them to the back of the building to where they dump them out. Then they dump them out, then someone, you know, messes around, digs it, and then they've got to carry those pots back to the wash station. Then they got to carry those pots to where they're going to refill them. Then they got to refill them. Then they got to carry the pots to where they're going to go once or twice more. So there's a whole lot more labor, and in fact, I would say that the labor actually costs you more than the soil or the nutrient in the long run. So, you know, kind of comparing those three things, again, if you're running a cocoa-based synthetic system, you're probably spending at least $100 per pound in synthetic nutrient, maybe more. If you're mixing your own salts, you're spending less. But either way, you know, compare that to a living soil system where you should be building soil, the cost of production should continue to go down over time, and you've alleviated the majority of your labor, and if nothing else, you can repurpose those man hours into more appropriate canopy management, training, pruning, IPM, and all that other good stuff that really rounds out a sustainable operation. I'm going to run through some pictures. I'm pretty much out of time, but I'll try and take a couple questions, and if not, come talk to me at the booth over the weekend. Here's some soil that we basically built in Northern California. The soil on the left, it's kind of hard to see, but that's what it's looked like when it started. The soil on the right, 3 years later, that's what it looks like. And that's basically just been created with mostly the addition of rice hulls and a little bit of compost and a healthy soil food web to break that stuff down pretty quickly. With a functioning soil food web, that rice hull is gone in a season, and it just looks like silty loam. It's pretty incredible. So here's a living soil bed. Got some oats and some clovers coming up. Here's a living soil greenhouse system, canopy. There's another one from it. There's a sunflower that came up from some of the cover crop that we let go just to see what happened. And you can't really see that, but that's flower. And there's some resources. There's us. And if you guys have any questions, I'll do that. And then I got to get out of here because we're running late. Thank you.